The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I'm so happy that yesterday I could call many children of +2 and we could have some good sharing between us, and of course only a few children are remaining, which I'll be doing in this week. You feel so happy when you speak, like sharing each other's feeling, like what is your present state of mind, whether you are comfortable or you need some more help from the teacher. It is always good, children, because when we are in the school, we were able to see each other and we could easily find out from your face whether the concept was easy for you, whether you are able to follow it. But when we don't see you, we find it so difficult, because unless and until you call us or we call you, we are not able to have a transparent idea of what is running in your mind. But yesterday I was so happy that I could speak to you all, children. Definitely I'll be doing this often, not only for you but also for me to get myself more energy when I talk to you. Okay, so now we are getting into our 5th chapter, surface chemistry. So we have been dealing with electrochemistry, chemical kinetics. So all the 4 chapters were having a lot of problems, but definitely this chapter, this theory is starting. Surface chemistry. From the name, it's very clear that chemistry that deals with the reactions or the situations that are happening on the surface of a substance. That's why it is also called as surface or interface phenomenon. What do you mean by interface? Interface means something that is between two surfaces. There is something that is between them, that is called as an interface, right? So surface phenomenon means the reactions or everything that happens on the surface that does not occur anywhere, only on the surface of the molecule or the substance. That process we call it as a surface phenomenon. In surface phenomenon, we are specifically looking into one particular topic, which is adsorption. Be very careful, this is adsorption, add. What do you mean by adsorption? Solid surface, they have a tendency, there are some solid surface. See, this is a thing that is happening everywhere around us, but we are not so keen in observing all this that is happening. When I say like, what is corrosion, children? Yes, corrosion is a process where we know the surface of the metal, that is iron, which is exposed, that gets oxidized into iron oxide when it combines with oxygen and moisture, that is water. So what is happening? Actually, reaction is happening on the surface of the metal. Why? Because that particular surface of the metal has got a tendency to attract what? Other molecules and retain. It does not allow it to go. It is retaining only on the surface which comes in contact, does not get into the bulk. What do you mean by that? When I say there is a this is my iron metal, when oxygen comes in contact with this, it forms a layer here, but it does not get inside the iron metal. So that's why we call it as a surface phenomenon. Like corrosion is the best example, right, for surface phenomenon. So when I say adsorption is what we are going to see this in this topic, we will see the definition. The accumulation of the molecular species at the surface rather than in bulk of a solid or liquid is called as adsorption. What do you mean by accumulation? Deposition. Accumulation is nothing but deposition. You go and get accumulated yourself, accommodated, deposited. So the accumulation of the molecular species at the surface, only on the surface it gets deposited rather than in bulk. It does not get inside the substance, does not get into the bulk of a solid or liquid. It can happen in the surface of a solid, it can also happen in the surface of a liquid. So such a process we call it as adsorption. Now in adsorption we know this is a solid and it has got a surface, and assume this is my molecule, it comes and gets deposited here. So what is adsorbate? This is my adsorbate. Why? Because this is the substance which comes into contact and gets concentrates, means gets deposited on the surface. So the substance which concentrates on the surface or which gets deposited on the surface, which gets accumulated on the surface is called as an adsorbate. Remember children, adsorbate, because we often get confused with adsorbate and adsorbent. Now what is adsorbent? Material on the surface at which adsorption occurs. So this is my adsorbate, this will be my adsorbent. Now this layer, surface of the solid is called as adsorbent, because this is the surface at which the process is taking place. So my adsorbent will take my adsorbate, which gets concentrates here, and the process is called as adsorption. You understood children? 3 terms we have studied. First one is adsorption. What is adsorption? The accumulation of molecule species at the surface of a solid or liquid rather than in bulk. What is an adsorbate? Substance that concentrates is called as adsorbate. What is adsorbent? Material on the surface at which adsorption takes place, right? Now how can I select? There are so many surfaces. Do all the surface acts as good adsorbent? No. Finely divided substances, because we have studied this in 10th standard or in 9th standard. When you cut the pieces, what happens? The surface area actually increases, right? When you increase the surface area, what happens? The process of adsorption becomes stronger, more adsorption occurs. So finely divided substances increases the surface area, thereby increases the process of adsorption. So what are the examples of finely divided substances I can take? Charcoal, silica gel, alumina, all these are examples of good adsorbent. It can come in 1 mark for you. So remember the examples of good adsorbents. Now if you see few examples children, when I take a closed vessel and when I add gases like hydrogen, oxygen, nitrogen and all, what happens is that since the vessel is closed, actually the pressure of the gas actually decreases. When it decreases, what happens? The moment I add charcoal into it, the gases, they get deposited on the surface of the charcoal. You can see the gases getting dispersed or getting accumulated on the charcoal surface. Another example is the dye, which you can easily see through your naked eye. If I take an organic dye which is mixed with animal charcoal, and when I am going to shake it, once I filtrate, after the filtrate I can see in filtrate it decolorizes, because the dye gets accumulated on the surface of the animal charcoal. So there will be no color in the filtrate. So these are the examples where adsorption occurs, right? Now once we have learned this adsorption, we are going to have a small idea, clarification between adsorption and absorption. Then we will get into the types of adsorption. Okay. What is a difference between adsorption and absorption? See, we have been hearing absorption. We used to hear absorb. It absorbs little water. or when I put a cloth in water, the cloth is absorbing the water, or when I put a sponge in water, the sponge absorbs water. Absorbs means sucking all the content into the complete substance, that is into the bulk. What do you mean by bulk? Throughout. When I walk in rain, if it falls only on my body, what is that happening? Adsorption. If I start putting the water into my mouth and it gets into the body, it becomes absorption, right? So adsorption happens only at the surface. When I say this is my substance, adsorption is occurring only on the surface. It is not getting into the duster now. It is only on the top layer. That is only at the surface of the adsorbent. But what is absorption? Not only on the surface, but it also gets into the bulk. It gets into the substance. That is called as absorption. So when it happens only at the surface, what will happen to the concentration of the adsorbate? I told you, adsorbate are the substances which gets accumulated. Excuse me children, which get accumulated or deposited on the surface of the adsorbent. So if this is my adsorbate, it is only getting deposited at the surface. So the concentration will be more, concentration will be where? It will be more only on the surface, because it is not getting deep into the bulk. So only at the surface area, the adsorbate concentration becomes more in the case of adsorption. What happens here? Since it gets into the bulk, it is, the concentration is throughout. It is on the surface, it is inside the bulk, throughout the substance, the concentration is uniform. That we call it as absorption. So here, it is a uniform taking of the substance. Adsorbate is no role for adsorbate here, because when I put a cloth in water, completely it gets wet. Completely the water gets deep into the thing. I will give you an example. Say this is my chalk. I didn't bring ink children, I forgot. I will just do the experiment in the next class again for you. Okay. Assume this is a chalk. Now if I am going to dip it into my ink, the ink spreads throughout my chalk. You can try this in your house also. The ink spreads throughout on the surface of the adsorbent. So my chalk is the adsorbent, ink is the adsorbate, but that is adsorption. But when I break it, inside it is white in color, I don't see any ink getting inside. So that is the difference between adsorption and absorption. You got it? Water vapor. What is water vapor? Moisture. Water vapor absorbed by anhydrous calcium chloride. When I am going to keep calcium chloride here, it absorbs all the water vapor. But when I keep a silica gel, it gets adsorbed. Only on the surface of the silica gel you can see moisture, that is water droplets on the silica gel. That is called as adsorption. So this is a small difference between adsorption and absorption. You may get in 1 or 2 marks question with an example. Okay. Now we know adsorption is taking place, absorption is taking place. But what is the chemistry behind that? Why adsorption is occurring? What is the reason for that? So we should be learning that as well. But what is that? We will see that this we call it as mechanism. What is mechanism? The real chemistry that is behind the process of adsorption. Particles at the surface and the bulk are in different environment. What is environment? I didn't say this is in the park or that is in the school. Not that environment. When I say this is my chalk is my adsorbent, the portion which is exposed, that is the surface part, will have a different environment, different force. And the particles which are inside the chalk will be having a different force. What does it mean? The bulk. What is bulk, children? When I take a substance which is inside that substance, we call it as a bulk. So in the bulk, the particles have got a balanced force. Why? Because they are not exposed outside. They don't get reacted with any substances outside the environment. So it has a balanced force. But the surface particles, the particles at the surface are having an unbalanced force, different type of forces, which we call it as the residual forces. We call those forces as residual forces. Now residual forces are responsible for this adsorption process. When I say adsorption, which is a surface phenomenon, definitely the forces which are present at the surface are truly responsible for the adsorption process, because they tend to attract and retain the molecules which comes in contact. Okay, so now we will learn about the mechanism in detail. So as I told you, residual forces are responsible for the attraction or retaining of the molecules on the surface. So residual forces, that is the unbalanced forces, are the factor which is responsible for the adsorption process. So what is happening when the forces are unbalanced and when the adsorbate comes in contact with the surface, it tends to get accumulated on the surface. So extent of adsorption increases. When it will increase? Only if the surface area is more. When the surface area becomes more? When it is finely divided. So when it is cut into small pieces, surface area increases, extent of adsorption increases. Now during the whole process of adsorption, there is something that is happening at the surface. What is that? Heat of adsorption. When the residual force is decreased, that is, once the substance comes and attract on the surface, the residual forces decreases. So what happens? The energy at the surface also comes down. When the energy comes down, heat will be evolved out. Heat is given out, right? When the heat is given out, we call it as exothermic process, because it is not absorbing the heat. Instead, when the particles comes and retains on the surface, some amount of heat energy is given out. That we call it as exothermic. What is del H? We know it is enthalpy. You remember children, energy change, heat energy, that is enthalpy, del H. So del H will be negative because heat is given out. It is an exothermic process, so which we call it as negative process. If you take an example like gases, when they come and get accumulated on the surface of a solid, we know gases have got high energy, they can move in any direction, the freedom of movement is very high. But assume once they come and falls on the surface of the solid, what happens to their freedom of movement? It gets restricted, right? It will not be able to move because they are already getting accumulated on the surface of the adsorbent. So it will not be able to move. Their freedom of movement comes down. What is freedom of movement? Entropy. Remember children, we studied in +1. Entropy change. What is entropy change? The randomness or disorderness, right? That is called as entropy. And we know entropy is again negative here. It becomes less because freedom of movement is less. So del S also becomes less, that is negative value. Now, when adsorption is occurring, there are two important things taking place. One is change in enthalpy and change in entropy, that is del H and del S both becomes negative in case of adsorption. But if you take a spontaneous process, because we were talking about spontaneous process which takes place on its own. When I say corrosion, it occurs on its own. I don't say iron, come on, go and take the water, or oxygen, come and fall on the iron. We don't initiate the process. It happens on its own, though it is a slow process. So for a spontaneous process, we know del G should be negative. What is del G? Gibbs free energy, that should be negative. And from thermodynamics we have studied del G is equal to del H minus T del S. Del H minus T del S, that is change in enthalpy minus temperature into change in entropy. But now if I want my del G should be negative, what should be the value of my del H? It should have a high negative value, because I know del S is negative. Negative into negative will become positive. If this is also becoming less negative value, the whole thing becomes 0, or sometimes they may be equal, or sometimes it can be positive. So now for del G should be negative, I should have a high negative value of del H, or else what happens? The whole process will reach a state which is called as an equilibrium. It reaches an equilibrium state where del H will be equal to T del S. You understand, children? So what happens? Del G becomes 0. So the whole process will reach a state of equilibrium. So this is the mechanism of adsorption. Adsorption is a surface phenomenon where because of the change in the residual forces and unbalanced force, the particles get accumulated on the surface of the solid. During the process, heat is given out, which is an exothermic process which becomes negative. So again, since the molecules which get accumulated get restricted in the movement, their del S also becomes negative. So according to thermodynamics, for the reaction to be spontaneous, we require a high value of del H, that is negative value. But actually the negative value, it comes down. As long as the adsorption process is taking place, more and more amount of heat will be evolved. So what will naturally happen? Del G will get a less negative value, right? So this is what is called as adsorption process. Now we will learn about types of adsorption, that is physisorption and chemisorption. So what is physical absorption, or I can say physisorption? The adsorption process, when it depends on the van der Waals forces. You know what is van der Waals forces? We have learnt in +1. Weak forces that exist between the molecules. So if the adsorption process is purely dependent on the weak van der Waals forces, such adsorption we call it as physisorption. In chemisorption, if the adsorption takes place with the involvement of chemical bonds, more important, children, because unless and until the adsorbate can form a chemical bond with the adsorbent, the adsorption will not take place. Such an adsorption we call it as chemical adsorption or chemisorption. So here weak van der Waals forces, here it involves a chemical bond. It is not specific, means any gas can come and accumulate because there is no involvement of the chemical bonds, but here it is highly specific. Only those adsorbate which can be able to form a chemical bond, those only get adsorbed here. These are reversible. You can take, it can occur in the reverse direction also. The particles can also get released. But here once it gets accumulated, you cannot remove it. So this is irreversible. In both the cases, it increases with the increase in surface area. I told you before only, if the surface area becomes more, the adsorption, extent of adsorption also increases. And both of them depends on the nature of adsorbate, especially in a physical adsorption. Easily liquefiable gases get adsorbed at a faster rate. But here, those are capable of forming chemical bonds get adsorbed at a faster rate. Here, enthalpy of adsorption is very low, it becomes negative, very less, but here it has got a high value in the enthalpy of adsorption. This is important. Physical adsorption takes place with a multimolecular layer, not only one layer get adsorbed. Once, example the same, duster I will show you. Once if it forms a layer here, again a second layer is formed, you can see a third layer formed. So which means it forms a multimolecular layer. It does not stop with a single layer. But what happens here? It is a unimolecular layer, only a single layer is formed during the adsorption process. Low activation energy. The activation, what is activation energy? The energy required to initiate, that is to make the reaction occur at a faster rate. Right. So here when I say low activation energy is required for the physical adsorption to take place. But here in case of chemical adsorption, definitely you require a very high activation energy. Now physical adsorption can also take place at low temperature. When I say favorable, which means only at low temperature physisorption occurs. When it becomes a high temperature, the physisorption actually decreases. That is, physical adsorption decreases with the increase in temperature. It is vice versa here. Chemisorption occurs only at high temperature. At low temperature it does not happen at all because that involves a formation of chemical bonds. So the difference between physical adsorption and chemical adsorption is also given in your textbook. Please refer the text because it comes in 2 marks to write the difference between physical adsorption and chemical adsorption. Now we will get into an important topic which is called as adsorption isotherm. So we will learn about adsorption isotherm in also solution phase. With that we will be stopping for today. Now you will see a video to understand what is adsorption and the difference between physical adsorption and chemical adsorption.
Types of adsorption and mechanism. Adsorption refers to the building up of a large number of gaseous molecular species at the surface of a solid. The surface of the substance that adsorbs the molecular species of another substance is referred to as the adsorbent. On the other hand, the molecular species which is adsorbed on the solid surface is termed the adsorbate. The adsorption of molecules on the surfaces of solids is a very interesting and useful phenomenon. Surface adsorption is at the heart of chromatography and ion exchange resins, to name just 2 examples. Let us understand the mechanism of adsorption. Adsorption is a surface phenomenon which arises owing to the presence of unbalanced or residual forces at the surface of a solid. These unbalanced forces are responsible for the force of attraction between the adsorbate and the adsorbent. Since adsorption leads to a decrease in the residual forces of the surface, there is a consequent decrease in the surface energy, which appears as heat. Therefore, adsorption is an exothermic process. Let us understand the thermodynamics of adsorption. At constant temperature and pressure, the change in Gibbs energy is given by the change in enthalpy minus T times the change in entropy. Since adsorption is an exothermic process, the change in enthalpy is negative. During adsorption, the entropy or disorder of the adsorbate decreases and hence the change in entropy is also negative. However, the value of the term T delta S is positive. Now, adsorption is a spontaneous process. For delta G to be negative, delta H has to have a sufficiently high negative value to offset the T delta S value, which is positive. As the process of adsorption continues, the change in enthalpy continues to decrease and finally becomes equal to T delta S. At this point, delta G becomes 0 and equilibrium is reached. The adsorption of gases on a solid surface is classified into physical adsorption or physisorption and chemical adsorption or chemisorption. Click each tab to learn about these adsorption processes. If the forces of attraction that exist between the adsorbate and the adsorbent are van der Waals forces, then the adsorption process is termed as physical adsorption or physisorption. If the adsorbate and the adsorbent are held together by strong chemical bonds, then the adsorption process is termed as chemical adsorption or chemisorption. Chemisorption is also known as Langmuir adsorption. Now let us look at the characteristics of physical adsorption. Click each tab to know more. Force of attraction. In physisorption, The forces of attraction are the weak van der Waals forces. Specificity. Physisorption is not specific to any adsorbent or adsorbate in nature. This is because this type of absorption is due to van der Waals forces, which are universal and not specific. Nature of adsorbate. As physisorption is non-specific, any gas will get easily adsorbed on the surface of any solid to a lesser or greater extent. However, easily liquefiable gases such as ammonia, hydrogen chloride and carbon dioxide are adsorbed to a greater extent than gases such as hydrogen, oxygen and nitrogen. Reversibility. Physisorption is reversible in nature. Disorption can take place readily. Effect of temperature. Physisorption is an exothermic process and it usually occurs at low temperatures. The amount of physisorption decreases with increasing temperature according to the Le Chatelier principle. Physisorption requires very little or no activation energy. Enthalpy of adsorption. Physisorption is exothermic, but the enthalpy of adsorption is quite low. It ranges from 20 to 40 kilojoules per mole. This is because the adsorbate is held onto the adsorbent by weak van der Waals forces. Physisorption is a multimolecular process. Surface area. The extent of adsorption increases with the increase in the surface area of the adsorbent. For example, finely powdered metals and porous substances that have large surface areas act as good adsorbents. Let us learn about the characteristics of chemical adsorption. Click each tab to know more. Specificity. Chemisorption is a highly specific process since it occurs by the formation of chemical bonds between the adsorbent and adsorbate. For example, oxygen is adsorbed on a metal surface by forming oxide. Chemisorption is a unimolecular process. Enthalpy of adsorption. The enthalpy of chemisorption is high due to the formation of chemical bonds. In general, this value ranges from 80 to 280 kilojoules per mole. A specific amount of activation energy is required to initiate chemisorption. Reversibility. As chemisorption involves chemical bonding, it is usually irreversible in nature. Surface area. Chemisorption increases with the increase in the surface area of the adsorbent. Effect of temperature. Chemisorption requires high temperatures. It increases with increase in temperature. This process requires a high activation energy. Let us summarize what we have learned in this module.
Now we are going to see about adsorption isotherm. What is isotherm? Iso means same, that is constant. Therm is nothing but temperature. At a constant temperature, we are going to see the amount of gas adsorbed by the adsorbent with pressure. At one particular temperature, we are going to see how the gas get adsorbed on the adsorbent with respect to the pressure. What is amount? Amount is nothing but the quantity, because we are not dealing here with quality. Instead, we are going to see how much is the amount of gas that is getting adsorbed on the adsorbent at different constant temperatures with respect to pressure. Now that was given by Freundlich. Freundlich was a chemist or a scientist who has developed this adsorption isotherm. Now what was his motive? He wanted to find out the quantity of gas adsorbed by unit mass of a solid. What is unit mass? 1 gram of a solid adsorbent and pressure at constant temperature. So when he was so serious in finding out the relationship between the mass of the gas adsorbed with respect to the pressure, he just gave an expression. He gave a mathematical expression saying x by m is equal to k into p power 1 by n. So here x is the mass of the gas which is getting adsorbed on the mass m of a solid. X is the mass of the gas which is getting adsorbed on the mass m of a solid. K is a constant, n is also a constant which is dependent on the nature of the adsorbate and the adsorbent, and P is my pressure. Now what I am going to do? I am going to take a log. I am going to take a log of x by m. So log x by m will be log k, and this into sign will become plus. So log k plus 1 by n log p. Now I am going to plot a graph between x by m and the pressure. Fraction of the mass of the gas adsorbed and the pressure. So what I will be getting? I am getting 3 different lines at 3 different temperature with respect to the pressure. So at this 273 Kelvin, this is the line I am getting. At 244 Kelvin, this is my curve. At 195 Kelvin, this is my curve. But we know, according to the straight line curve, y is equal to mx plus c, the graph becomes valid or the equation becomes valid only if there is a straight line. Unless and until I don't get a straight line, the equation is not valid. We have studied in the equation of straight line, right? So what happens here? Slope is my 1 by n, intercept will be my log k, but I am not getting a straight line. So what am I supposed to do? I would say the equation has not become valid till now. So then comes the adsorption isotherm in solution phase. But before that, we have to put the values for 1 by n. 1 by n, when I say p raised to 1 by n, this 1 by n can have values between 0 and 1. If it is becoming 0, let us assume 1 by n is 0. Anything to the power of 0 is nothing but 1. So k into 1, x by m will be equal to k, which is my constant. So that shows x by m is independent of pressure. It does not depend on pressure. Whatever may be the pressure, I will get a curve. That is what is when 1 by n becomes 0. But when 1 by m becomes 1, p to the power of 1 is p. So x by m will be equal to k into p, or I can also write x by m is proportional to p, which means the value of x by m is directly proportional to my pressure. When pressure increases, this increases. When pressure decreases, x by m decreases. So these two values, conditions of 1 by m, makes the equation stated at different values. Right. Now we will see how to make this expression more valid with respect to equation of straight line. So we will see adsorption isotherm in the solution phase. We were telling that Freundlich adsorption isotherm was not valid with a straight line, right? But when it was compared with a solution phase, because I told you adsorption does not occur only with solid surfaces but also in the liquid, that is from solutions. So solids can also adsorb from the solutions. What happens exactly? Like when acetic acid is mixed with charcoal, you can see on the surface of the charcoal acetic acid is getting adsorbed, right? That is actually decreasing the concentration of the solution, because as the acetic acid particles get sticked on the charcoal, the concentration of the solution comes down. What is the process actually in the solution phase with respect to adsorption? The extent of adsorption decreases with increase in temperature. When the temperature becomes more, the extent of adsorption decreases. But when you increase the surface area, the extent of adsorption increases. So it increases with increase in surface area but decreases with increase in temperature. It depends on the concentration of the solute. What is solute? The solution, you have solute and solvent. So it depends on the concentration of the solute and also depends on the nature of the adsorbate and the adsorbent. Most important factors. So Freundlich, since that equation with pressure was not valid, instead of pressure, he tested with different samples at different concentration. So he reframed the equation as x by m is equal to k into c power 1 by n. Everything is the same, but instead of pressure, C, that is concentration, is what we are using. But once equilibrium is achieved with concentration, when you take the log on both the side and plot a graph between log x by m and log c, what do we get? We get a straight line. You get a straight line which shows that this equation is valid. Now to test that, what he did, he took 5 different flasks and he took 5 different volumes, that is 5 same volumes of charcoal at 5 different flasks, A, B, C, D, E. He put charcoal of same volume in each flask and he took different concentration of solution of acetic acid but he put at equal volume. Say 0.2 concentration, 0.1 concentration, 0.01 concentration, but the amount that he is putting in the flask was the same, 5 ml, 5 ml, 5 ml, 5 ml of acetic acid, and charcoal was the same. But after the adsorption is completed, what happens? He took the final concentration of the flask. Then initial minus final will be giving us the value of x. That shows that it has to be a straight line and definitely the equation is valid. Now with this, the Freundlich adsorption gets over. You have in page number 127 old textbook, new textbook I am not sure with the page number. You can see some of the applications of adsorption, children. You can read 3-4 adsorption. Make sure that you read the entire thing. Around 10 applications are given because they can ask in 1 mark any one application, but if they ask you to write any 2 application, it's of your choice. Whichever you feel you are comfortable with, you can select the application and write it. Okay. With this, our first topic, that is for today's class, it is getting over. I hope the video was useful for you, and the next class we are going to start with catalysis, that is catalyst playing an important role in adsorption. That will be very interesting, and I will try to include some experiments in the classes as well. Let me just see to it, and if you have any doubt, please ask me, children. Try to call the teachers whenever you get free time. Okay, please do remember your teachers. Okay, thank you. Have a great day. Stay home, stay safe, be happy. Thank you, children. Bye.